Okay, so this is my first ever video on YouTube, so please show some support. Um, this first problem is taken from SS Proto, which is problem number 1.16. Wait a second, yes. So it says that there is a bobbin roll and the inner radius is small r, outer radius is capital R, and a thread is wound around this, and the thread is being pulled by velocity v. There is a board which is hinged at the point B, and currently it is forming an angle alpha. So it is very obvious that the bobbin roll will start moving towards right, and as it does so the board will also start rotating clockwise. So it says that find that angular velocity omega of that board as a function of angle alpha. So I have mainly discussed two methods here, the best two methods. The first method, it is purely physical, like pure physics. So I draw this diagram again, and I assign the angular velocity of the bobbin as omega dash and the velocity of center of mass as v dash. So it is evident that v dash equals to r into omega dash because the bobbin is purely rolling. So if you look at this point, which is on the thread, it has a velocity v, which is given. Now this v is equals to v dash plus small r into omega dash, the velocity of center of mass plus the additional rotational velocity, right? So that equals capital R omega dash plus small r omega dash. So we get omega dash, the angular velocity of this bobbin, equals to v by r plus r. So the v dash, the velocity of the center of mass of this bobbin roll, is vr by r plus r. Now I join this point to the center of the bobbin. I also draw a perpendicular line here, and this is the point of contact C. This board is rotating with some angular velocity omega. Now look at this point, the point on the bobbin roll. It has a rotational velocity along this tangential direction, which is r omega dash. It has also the velocity of center of mass, which is v dash, and the angle between them is just alpha because this line is parallel to the base, and this is secant, or whatever you call it. I don't remember the term exactly. So this angle right here is alpha by 2, which is basic geometry, right? This is the line joining this to this, and this is a tangent, so it divides this angle. This is also a tangent, so this line basically bisects the angle. I think it is some class 10th geometry. Okay, so, and this length right here is r by 10 alpha by 2. Again, this is a right angled triangle. This one is alpha by 2. This is capital R. So this length right here is r by 10 alpha by 2. Now, notice this is the most important statement here, which says that if two bodies are in contact, then their velocities along the normal to the point of the contact must be same, which is quite obvious, right? If the velocities along normal are not same, then one will get detached from the other. So here the normal direction is the one shown in the red arrow. So the essentially this constraint is this omega r divided by tan alpha by 2. So omega into the length, which is r by tan alpha by 2, gives the linear velocity of the board at this point. That is equals to v dash into sine alpha. So the r omega dash, the tangential velocity, has no component along this normal. Only the v dash velocity has a component, and that is v dash sine alpha. So just I write tan as sine by cos, and I put the value of v dash from this equation, and I apply that multiple angle formula. So sine alpha equals to 2 sine alpha by 2 cos alpha by 2. Cancel the cos term, cancel the r, so we get omega equals to 2v sine square alpha by 2 divided by r plus r. This is our final answer. Now coming to method number 2 here, I have to drop a perpendicular here. I call this distance x. So we have already derived that v dash equals to vr by r plus r, and this angle is alpha by 2. So now tan alpha by 2 equals to r by x. I have to isolate x here because I want to differentiate this, right? So x equals to r cot alpha by 2. Now differentiate this, we get dx by dt equals to r minus cosec square alpha by 2 into half into d alpha by dt. This is just chain rule. So I write this as minus d alpha by dt. I take the minus from here and I put it here. So minus d alpha by dt is it has a special physical significance, right? Because omega is in clockwise direction, I have already assumed that it is clockwise. So that means that alpha is going to decrease. So minus d alpha by dt is nothing but omega. Also look at dx by dt. If the velocity of the center is v dash, so the velocity of that point which is in touch with the floor is has also velocity v dash. I'm not talking about that instantaneous center of rotation that has zero velocity, but I'm talking about the point of contact here. Like, it is hard to tell what I'm trying to say is that the point of contact here, it does have a velocity, but when we say that instantaneous center of rotation, we do not mean this point of contact here, we mean the point on this rolling wheel which is at that moment contact. So that point is a fixed point, right? And here this point of contact is a variable point. It is constantly moving towards this direction with a velocity v dash. But that instantaneous center of rotation, that indeed has zero velocity. So that do not like confuse between them. So dx by dt is nothing but v dash because this point is moving here with v dash, and that means that it is basically the rate of increase of x. So again, v dash put vr by r plus r, and we get omega. Okay, we cancel the r, we get omega equals to 2v sine square alpha by 2 divided by r plus r. All right, so thanks for watching. I will make better content in the future, and thanks for the support. Make sure to like and sub.